Thank you for coming. This is my second BSides-Calgary. And thank you, BSides, for getting me back again. Ready? Okay, we're going to look into a malware's on-demand polymorphic code. It's kinda a bit more too technical maybe, but I hope for you to enjoy it. Okay. About me, that's why I want to walk around. I want to see my slides too. Okay, I work at Fortinet. Okay, I have published some articles in various bulletin and regular contributor for our blog.fortinet.com. Those are some of my conferences that I went to already. The red one is the BSides, the current one. Okay, most of my profile picture looks like this, but deep inside, that's me. Okay. It's kinda supposed to be Batman, but kinda morph into him. Here, there are different malware categories that we already know. Okay, it is very already hype in the news, in the media, and most especially the ransomware. Okay, but this particular malware is not just a ransomware, it is also a virus, which is a file infector. Most ransomware that we know, they just lock your screen, encrypt your files, and that's it. You just have to pay by Bitcoins, and then you can get your files back. But this one, if you pay by Bitcoins, there is a chance that you can be infected again, because it infects the files and runs it again. Once you, for example, your calculator.exe was infected, okay, when you click, you want to compute something, and then you click it again, you will be infected again by this ransomware. So it is a combination of a ransomware and a virus, okay? Just the introduction. Okay, we're going to look into this particular malware. We're going to check how it works when you try to reverse engineer the malware. We're looking into some of the visible signs. We try to extract the infected file, okay? And we're going to look into also the different algorithms, the metamorphic and polymorphic algorithm of this particular malware. Okay, what is a file infector? It is a kind of malware that attaches itself into a host file, okay? It depends on what kind. It is a pending, pre-pending, cavity type, okay? Okay, it also maintains persistency, and of course, infected files are harder to restore, okay? The best way is to format your system, reinstall the Windows or your whatever. But it's not very advisable because it will clean up your hard drive, okay? And a ransomware, of course, we learn there are literally hundreds of ransomware roaming around, okay? This one is particularly holds your computer for ransom, locks your screen, and uses, of course, Bitcoins for payment. And, of course, totally luxury. We're going to look into how to unlock your screen if you're infected with Virlock. Okay? But you can also use the same technique if there's a new malware that locks your screen. I hope it works with that one too. Okay, as a common malware, we normally use different tools, but most of the time we use this one. We use debuggers to unlock. There are several debuggers that we can download for free. Okay? We have the Oli debug, the immunity debugger, and if you want to, the difference between the first two is that immunity debugger uses Python script to enhance your reversing script, okay? So we have x64DBG, wherein if you're analyzing 64-bit malware, you can use this one. Because I think they stopped enhancing only DBG, but for x64DBG, you can debug 32 and 64 at the same time, okay? For when you encounter a sample of Virlock infected file, okay, you can only see the MZ header, the decryptor that decrypts the encrypted file, okay, and then of course this particular part is, oh, I think I have a pointer. This particular part is actually the encrypted version. But when you look inside the file, okay, normally when you try to unpack this one, okay, you can use now static or dynamic analysis with the decrypted unpack. That is the common malware strategy. Okay, but this one is kind of different. There are several reversing stages for Virlock. The first one is, okay, the lower part of the infected file is a metamorphic algorithm. We're going to look into that. Then after the metamorphic algorithm, it will generate the decoded bytes, which is responsible for the main function. The main function generates the different on-demand polymorphic code, wherein I call that on-demand because every time it executes, for example, one function executes to drop the file, it will re-encrypt with another key. That's why every time it uses that function, it will have a different copy of the malware itself. Even if you're debugging at the same time with your friends, and then the copy in your memory is different from different computers, okay? So that's why I call it on-demand. So when you run the on-demand, when you run this malware, and then after finishing up some of the codes, it will look something like this. Like if you try to color it, it will become like a Christmas in your memory, in your computer memory. Okay? And finally, the last part is your host file. If you want to clean your infected files, all you have to do is to extract this particular part, and then you get your host file back. Okay? As a ransomware, okay, normally the good thing with, no, not good thing. The important thing with ransomware is when you're infected by a regular malware, sometimes, most of the time, you never know. Sometimes it is a Trojan that gets your password, that collects your information, and you'll never know. One good thing, or not good thing with ransomware is there's always a visible sign. Like this. Very visible, right? Or maybe I'm already infected, right? The first time when you're infected with Virlock, you will see a blank screen followed by this. Okay? I executed that in Canada, of course, we're in Canada. If you live in US, those flag and those things will change. That 250 CAD will become 250 USD. It depends. The malware knows where you are. Okay? And if you don't know Bitcoin, okay, if you happen to know, if you're asking, what is Bitcoin? One of the important thing by ransomware is it explains something. It is kind of educational for those people that don't know Bitcoin, okay? And the good thing is, if you already know Bitcoins and you don't know how to pay, how to get the Bitcoins, this particular malware gives you information where to get the Bitcoin. Actually, in Vancouver, there is one in downtown Vancouver. There is a machine. It is like an ATM. You put your money there, your cash, and then they will give you a code for the Bitcoin. There's also one in Seattle, USA. I went there. You can actually exchange your money with the Bitcoin. The problem is it needs your driver's license in order for you. So I did not try to do that. Okay, if you live somewhere not in Vancouver, you can click your location, then it will give you the location where you can get your Bitcoin. And then it will just go around. Those are the visible signs. If you're infected with WannaCry, if you're infected with Petya, you will see visible signs. That is ransomware. Okay, this particular ransomware is, I selected this one because it is also a file infector, as I've said earlier. But looking into different kinds of file infector, okay, normally we have a pending, pre-pending on top. Okay, the MZ is the host file. The cavity is harder to clean because it inserts the malware, the file infector in between those spaces. Okay, and then the overwriting, they delete the whole host file. Then there's no solution for that. And then you have now the companion. Virlock is kind of a different category because it gets your host file, encrypts it, and put it in the body of the actual Virlock. Okay? That is how Virlock works as file infectors. Okay? Normally, to clean the infected file, you have to know what kind of viruses it does, and then now you try to extract and restore the file. This one, all you have to do is to like create a script file, look for the key, encrypt it, decrypt it, and then you can get the host file. Okay? Extracting the host file, we just need to look for the decryption key. I will show you where it can be found. It can be found later, and then use that. The decryption key is only used as simple XOR. If you know that XOR is just trying to change it byte by byte. Okay. Okay, going back to the extracting of the host file. First, if you're going to look at your Hex Editor, it will look something like this. There's nothing to see, okay? And then you have to find this particular code, wherein this code will give you the initial key, the location of the decryption key. Okay, these are actually, you can actually find it, just look for this offset, particular file offset, and then run the decryption code, get the decryption key, and then the next D word will be decrypted, and then the next D word, and the next D word, and then finally, it will give you this. This is now your decrypted file. That is your host file. That is the name of actually the host file. This is the process explorer. This is the start of the host file. All you have to do is to cut that particular part of the code up to the end of the file, and then you already have your host file. All you have to do is to use or to create like Python script or some other script to extract the file. That is how easy it is to clean the Virlock if it is not yet enhanced yet. I think it's already enhanced. We've seen some of the new samples that we have. Okay, so this is the key. All you have to do is to look for that key. And then that's the host name, okay? And that's it. You already have your decrypted file. That is how you extract the infected file. As a metamorphic is a different kind of algorithm wherein it tries to encrypt or decode or encode your file, wherein it's because it is metamorphic, your antivirus engine sometimes it is hard for it to recognize that it is a malware because it can still run the code. The problem with this one is when you say metamorphic algorithm, the basics, let's look at the basics. Okay, for example, you want to put a value 0 in a certain register, which is like a variable in assembly language. For example, you want to put value 0 to EAX, you can do that in several ways. Okay, you can put 0 to EAX, you can XOR EAX, you can subtract it, you can do this, and then everything will result in the same thing, which is the value of 0 will be placed to EAX. Okay, that is how metamorphic code works. Okay, if you're going to scan it with your antivirus scanner, it will look like as just the regular code. Even it is sometimes hard to tell if it is malicious or not. Okay, it is hard to find similar bytes because it tries to reorganize the code. Okay, unpredictable code and unknown length of bytes. Okay, the generated metamorphic code, which is on this particular part, the lower part, that is the very first one to be executed. Okay, and then a maximum, different sizes, a maximum of approximate 28 kilobytes, and then all you have to do is to look for something it will end. And then if you want to follow, reverse the malware, all you have to do is to look for the escape or the jump or the call. Okay, we'll see that a bit later. I compare sample 1, I have sample 1, sample 2, different infection algorithm, different infected files, okay, wherein this particular group of codes is only used to decrypt this particular 4 bytes. Imagine if you're trying to analyze the malware, okay, and you only have 1 hour. Okay, because the customer is already infected, you only have 1 hour to analyze the malware code. And then this one is only decrypting 4 bytes from here to here. Another set of codes to decrypt another 4 bytes. Imagine how much longer you're going to generate the actual malware to analyze. Okay, that is the first sample that I have. Okay, the second sample, I didn't remove the square to compare that the next sample has a smaller number of codes to generate the same thing. Okay, this one, the first sample has longer codes for the second dword. Dword is just 4 bytes. And the third dword is, the code is longer, but they still generate the same code. All you have to do is to look for those things if you want to scan that particular set of malware, okay, to scan all the files that is already infected. All you have to do is to decrypt the malware first, okay? And then you have to find that code. Okay, that's sample 1. This is sample 2. Okay, another set of comparison. Okay, even the registers that is used is different. Okay, EDI, EAX, sample 1, sample 2, wherein if you want to make a detection, all you have to do is to look for this code. Okay, and then you can detect all the infected files. Let's look some of the, so this is how the Metamorphic runs in a debugger. I use only debug for this one. Okay, it tries to decrypt that particular 4 bytes and then runs the second set of code. Okay, decrypt another set of 4 bytes, and then until it runs, it decrypted the whole thing. Take note that it is only decoding the first set of bytes as the first set of codes earlier. It is not yet the main function. We are not yet in the polymorphic code, right? So it is decrypting those things. It is not running anymore. Okay, you can see that the code is changing. One thing with the metamorphic malware, metamorphic code, is every time that they do the metamorphic code, there's always a jump out, a call out. All you have to do is to look for this one. So this particular technique doesn't only work for this malware. If you encounter a new malware that uses metamorphic code, all you have to do is to look for the call out or the jump out, put a breakpoint on that particular code, run the malware on the debugger, and then that's it. It will stop on that particular call or jump, and then you have now your decoded code. Okay, somewhere at the end, okay, of this one, okay, there will be a jump out, a call out. Notice. Look for that one, for the metamorphic code, and then breakpoint. Once you go back to the code, you will see the same decrypted code, which is the metamorphic. Okay, this one, this is the same. Okay, that is how you try to beat metamorphic code in any malware. It doesn't apply only to this one. It's only for the rest of the metamorphic malware samples. Let's go now to the polymorphic. Okay, we executed this one earlier. That's the metamorphic code. It only produces the decoded bytes, and now the main function produces this one. Okay, let's now see what happens to the on-demand polymorphic. Okay, what happened is it uses a decryptor. All you have to do is to look for, okay, for the decryptor code. Okay, the decryptor code, okay, the malware author makes it harder again. Okay, they put garbage code wherein those are the codes that you don't actually need. Okay, but they put it in order for you to make the analysis longer, harder, right? Garbage code, redundancy check, but it only uses a regular XOR algorithm. Okay, this is the general code. These are the, hey, it doesn't show the code. It shows here. Oh, it's not working. It's supposed to be showing the code here, which is not there. Okay, those are supposed to be the code. Let me see again. Oh, you can see from here, the small one. It should be something like this, okay? And then some of the red one should be the garbage code, which is not to be used by the malware. It uses this one, the RDTSC function is the one that generates a random key. That's why whenever it runs that code, it goes back, it generates another key, okay, for it to encrypt the malware back again. And then it uses the new key. And then, but it is still using the simple XOR bytes, XORing of the code. Let's see, what this one looks like. This is the one that generates the new key code. And then you now have your new key. Okay, you can see that for this particular part, okay, this part is the key, and then once it generates back, you will see that there is a different key that it uses for the next set of encrypted bytes. And that is your on-demand polymorphic algorithm. And then it just encrypts. So the process is, it decrypts, it runs the code, encrypts it back with another key. It will look something like this. This is your original, or the first encrypted bytes, encrypted codes, okay, with the old key. I just get the first 16 bytes here. And then once it is decrypted, it executes, the malware executes that particular code, and then once it is done executing that particular group of code, it now decrypts it with the new key. Okay, take note that these are the same set of codes, okay, based on this one, okay, but they are now different bytes, okay, because of the on-demand polymorphic. Okay, how do you detect this kind of samples? All you have to do is to wait for it to be decrypted, and then get the detection here. Because every time, even though other samples is different from each other, okay, but the decrypted code is always the same. So all you have to do is, if you're trying to make a scanner to detect this sample by script or your antivirus engine, all you have to do is to look for the decrypted code, and then you can scan the rest of the infected files. Okay? And also from the code, you do not get from the code wherein it contains the garbage code, because it changes. It always changes. So you have to get it from the decryptor itself. Okay? Let's proceed now in unlocking Virlock. Going back to the screen, we're actually very fast. Okay? So again, this is your screen. And then if you're infected with Virlock, you cannot do anything. You can always just go around. If you're infected, you can just go around until you pay by Bitcoins. Okay? That's the only thing that you can do. The only problem is, can we unlock? Okay? Because if we unlock this one, we still have another problem. Your files are still infected, right? So I'm going to show you how to unlock, and then probably just download some clean files or run your antivirus. Because if your screen is locked, you cannot even run your antivirus software, right? So we're going to unlock this one. So I execute this one with my XP. I executed it in real time. So I'm infected. That's how you see that you're infected with. So real time, I restart the machine. Okay, it looks clean. And then I put some timer for us to know if there's nothing. So when you restart your computer, it looks like you're not infected anymore, right? Because I was infected, I restart, I waited for it to because when you restart your Windows, you still have to wait for the rest of your applications, right? It looks like it is not infected anymore, okay? But somewhere around, how many seconds? I think 3 days. I think we don't have enough time to, no, I'm just kidding. So real time, but if your machine is faster, this machine is actually slow. If your machine is faster, probably a few seconds, and then voila, you already have again your Virlock. So this one, in 52 seconds, 53 seconds, it will show again your infected files. Actually, with this one, you cannot actually run this. So this particular part is actually showing you how to unlock the Virlock. All you have to do is If you're using Windows, okay, run it in safe mode, right? Safe mode. I am now in safe mode. The good thing is the malware is not running during the safe mode, okay? Afterwards, go to your registry editor. Take note that this particular technique, okay, can also work with other samples, okay? Not just Virlock. Okay, look for usually the startup key, the run. Just search for run. I am on safe mode. I'm running registry editor. Okay, as you can see, there is an executable here that is actually runs the malware, the Virlock. All you have to do is delete that malware. Okay, but the malware actually has two. Okay, the other one is the backup. Okay, find another one, find the backup file. Okay, there's another one. Okay, if you're infected with Virlock, there are two files running in auto start mode. Okay, you have to delete both of them. And then now you can now restart your machine. Okay, remember earlier when we restarted the machine, 52 seconds from the boot up, okay, it will show again the ransomware note, right? Let's see if it is still infected. Running in real time, I restarted after deleting the auto run registry key. Still running. "52 seconds, we will see, supposed to be, if you're still infected, oh, you are actually still infected because we just clean the screen up, the lock screen, right? We just remove the lock screen, 52 seconds, 53, 54, so your lock screen is actually the particular part that we deleted from the registry editor is actually the one running the screen, the locking, that is actually the malware code. Okay, so now, we unlock the screen, but again, as I tell you, your machine is still infected. Okay, your files are still infected. Okay, you have to do after this. Okay, so the screen is okay. You can now install your antivirus software or your script that you created to get those files. Or if you don't have any important files in your system, just install a new one, okay? So that is 143, 145, and so on and so forth, and then that's it. Your screen is unlocked. That particular technique can work in other malware too. Oh, we're done. Not yet. Okay, in conclusion, only in 30 minutes. Okay, some challenges in a ransomware is sometimes it's hard to unlock your machine. Okay, you have to, if it is a file infector at the same time, you have to extract the host file. Okay, for the metamorphic malware, producing the main malware code is sometimes it's hard if you're making a, for example, virus report or something. Okay, as a polymorphic, it's hard to understand the malware code. Most of the time, it takes you a longer time to look into that. Okay, there are some possible solutions is, okay, removing the registry entries to unlock your machine, running A/B security products to clean the system. Okay, you can create your own scripts just look for the key, right? And then all you have to do is to run XOR within those bytes, and then that's it. You have now the solution. Okay, metamorphic code, as I've shown you earlier, all you have to do is to look for the jump out, the call. Most of the time, it has the call, it has the jump out. Then breakpoint on that, and then you will be able to read the metamorphic code or do the decoded code. And then, of course, the last part for the polymorphic malware, Okay, dumping the decrypted code is very important when you try to analyze it in more on dynamic and static analysis. And that's it. Only 30 minutes. We have enough time for questions and questions. Not sure if we have an answer. Question?